Welcome back. Here's page 6 of our semester 2 exam review guide. Find the sum of the infinite geometric common ratio. And our ratio can be found by taking a term and dividing it by the term before it. And we could, if we're told it's geometric, we could do that with any term. I could put 8/9 on 8/9 on -4/3. I should end up reducing to -2/3. So we're looking for the sum as x goes from 1 to infinity of this entire sum, and this is a frog on the log problem. So it would be something. We don't even have to write this in here if we understand each jump is shorter than the jump before, and we've got our ratio. The form of that becomes, or the solution becomes, a1 on 1 minus r. So our a1, our first term, is -3 on 1 minus r. That's 1 minus negative, or 1 plus 2/3. We get -3 on 5/3, or -3 times 3 on 5, or -9/5. And there we have it. Okay, find p k plus 1, the k plus first term of this sequence, where pk is k times 3k plus 1. Guys, this is just like a function. This says our function is p of k is put k here and put k there. But I want p of k plus 1. So I'm going to put k plus 1 here. In place of this, I get k plus 1 times 3 times, I'm going to put k plus 1 where that k is, and there's still another plus 1 out here, and then I would probably start simplifying that. Do I need to simplify that? Doesn't look like it, because they didn't do it here, and we've got exactly the same thing. It's just a function. Find the sum. This one is another calculator-friendly problem. Clear. Let's go alpha window summation. X equals 1 to 13 of x, and that fifth needs to be inside these parentheses. Talked about that back on page 5. Raised to the fifth. And we see that gets big in a hurry, but the solution is B. This is combination 10-4. This is the same as how I write it often and how Excel likes it, or 10C4. They all mean the same thing, and we've got combination available to us. Is that in alpha window? It is there. If you don't have it there, I know you can get it by going into second. We want to go to math, or just into math, probability. It's right there as well. So we just want 10C4. 210. Should be able to do it by hand, but don't have to for the final. Expand. This one we're going to need to know the rule. To the fourth row of Pascal's triangle. Here we go. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. That's considered third row. 1, 4, 6, 4, 1. So I need 1 of the 2a to the fourth, plus I need 4 of the 2a to the third times the -b to the first, plus I need 6 of the 2a squared times -b squared, plus I need 4 of just a single 2a, but 3 of the -b's, plus 1. None of the 2a's, but 4 of the -b's. So let's see, I get 2 to the fourth, 16a to the fourth. A negative times a positive, negative. Let's see, 2 to the third, 8 times 4, 32a to the third b. 2 squared 4 times 6, 24. -b squared, that becomes positive, so this is plus. Oh, before that I've got an a squared here. Negative squared plus b squared. And I've got an a squared, as I said. And here we've got 3 negatives, negative times positive negative, 4 times 2, 8, a single A, 3 B's, and 4 negatives, positive B to the 4th. So it's looking, not quite, pretty close, 16A, negative 32A cubed, 24, looks like we've got it A. All right, accountant numbers from Northern Oil Company insist on 11 digits if the first digit cannot be 0 or 1. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digits. How many choices for the first digit do we have? There's 10 digits, but I can't use 0 or 1. I've got 8. But after that, I've got 10 choices and 10 choices, dot, dot, dot. So it's 8 times 10 to the, there would be 10 of these. 8 times 10 to the 10th. That would imply 10 zeros. 3, 6, 9, 10 zeros. We got it. There it is. 34 is A. How many different arrangements can be made out of the letter math? We could just grind this one out, but we could say, and the nice thing here is there are no repeats. So this is, we're just getting all the different permutations of the letters math. How many choices for the first letter? 4, then 3, then 2, then 1, 12 times 2 times 1, 24. We'll look at distinguishable permutations a little bit later. Okay, a college has 9 instructors qualified to teach a special computer lab course which requires 2 instructors to be present. How many different pairs of teachers should there be? So we're going to choose 2 out of 9, a subgroup from a group. And so what should be going on in our head? Is this a combination or is this a permutation? Is there anything here that implies that the order that those instructors are chosen matters? Requires 2 instructors to be present. No, it's not like one is presenting material and one is tutoring. It's just 2 instructors present. That's all we know. Therefore, this is combination. We've got 9. We want to choose 2. And we could do that pretty easily by hand, but you can also, I'll just second enter this to get to combination. 9 delete 2. And we get 36. And finally on page, last one here, let me just move this up a little bit. 8 cards are drawn without replacement from a standard 52 deck of 52 cards. How many sets of 8 are possible? So this is either combination 52, 8, or permutation. When they say sets, isn't A, B, C, D, E, F, G, H the same as H, G, F, E, D, C, B, A? The order doesn't matter. Combination 52, 8. Second enter. Let's see. Combination 52, 8. Whole lot of hands. What is that? That is 75 million. Or is it more than that? 752,538,150. A. All right, there is page 6. Page 7 be coming shortly.